Hello everyone, welcome to our channel Tech World. So today we are going to discuss about the latest, and it will be going to a very good advancement in our wireless industry. Okay, related to 5G and 6G. So this topic basically that we are going to discuss is 5G NTN. NTN basically stand for non-terrestrial network, and whatever the network that we are using on the land. Okay, so whatever the network related to 5G, 4G that we are using, okay, and the tower base signaling that we are the communication is being done on the land. That is basically the terrestrial network. And when you talk about the non-terrestrial, so you can see the background picture. Basically, it is replicating, or basically it is telling us about that this is related to or referred to the communication through the satellite. Okay, so there will be no cellular towers directly come into the picture or fiber optical cables. Okay, so and there are a lot of platform for this NTN. Okay, so in this particular, we can say the satellite network will come into the picture. HAPs HAPs is basically a high altitude platform. Okay, and there is aerial platforms. Okay, and underwater communication is there. Underwater communication network. Okay, so basically underwater we can't consider directly as an NTN, but yeah, anyhow it is not using the land for, or the terrestrial one for the communication, so we can put it in that non-terrestrial network bucket. Okay, so let's start with the today's topic, that is NTN, non-terrestrial network overview. Okay, so first of all, that I have already mentioned you what exactly the NTN is. Okay, we will go much more deeper into this. Okay, but if we'll go with the straight technical line, or a straight theoretical line, so non-terrestrial networks typically refers to the communication networks that do not rely solely on the traditional terrestrial infrastructure. Okay, so traditional terrestrial infrastructure that we are referring to the land-based cellular towers, fiber optics, cables, and all. Instead, the NTN leverages various non-terrestrial technologies and the platforms that I was already mentioning you, that about the satellite network. Okay, satellite network. Okay, and HAPs. Okay, aerial platforms, underwater communication. Okay, so when we talk about all these things, so satellite network, what exactly we are referring to the satellite network? So in the satellite network, this is one of the common form of antenna that very regularly we are seeing. Okay, so satellite in geostationary orbit, or you can say the lower earth orbit. So we will discuss further about the orbits. Okay, where exactly we are placing our satellite. So this is basically Leo. Okay, and other two are also there. Okay, we will discuss in depth for this particular orbits. Okay, but it is like Leo, Geo, and Mio. Okay, that is low Earth orbit. Okay, geostationary Earth orbit, and medium Earth orbit satellites. Okay, so these are the type of satellites that we will talk further. Okay, and when we talk about and this orbit provides the broadband internet. This is basically used for the broadband internet access. The Leo one, telecommunication services, data connectivity, where like remote area or what you can say unserved areas. Okay, and when we talk about the other NTN type, that is HAPs is basically high altitude platform. So this is basically uh, the concept is like we are putting small balloon like inode bees. Okay, balloon like inode bees of around like 2 kg or 3 kg in a weight, okay, in a stratosphere, okay, and that basically will charge with the, what you can say, the solar energy. Okay, so this balloon will behave like a E0 B and G0 B, and this can give the network, or this can facilitate the wireless service to the, basically like you can take an example like airlines and all. Okay, so they will be moving on that particular layer, so there it will be leveraging the coverage, and it will be providing the wireless communication and the internet access to the people who are sitting in like aeroplanes or like helicopters and all. Okay, so this is what exactly the HAPs means. Okay, and other communication, underwater communication. Okay, so they are also the like oceanographic research or underwater surveillance. For this kind of purpose, we are using the NTN networks on the under for the underground communication also. So this is what exactly you can understand about the NTN. This is what exactly the non-terrestrial network refers to. Okay, here I have put two diagrams. Okay, so to illustrate the common, or illustrate just how exactly the connectivity and what are the components basically involved in this NTN. So you are able to see there is a this is a satellite. We have a feeder link to the gateway, and this further gateway is connected to the data network. Okay, and the user equipment that we are talking about, that will be directly connected to the satellite via service link. Okay, so when we talk about the links, there are different links we are talking. Okay, especially you can see I'm talking about the feeder link, service link. So what exactly these are? So you can see in a figure the feeder link that we are talking about. Let me clear this. Okay, so the feeder link, you can see the feeder link between a gateway and the satellites. So this link represents the radio connection between the satellite gateway, okay, and the satellite to exchange the data and the signal. Okay, and when we talk about the service link in a figure, you can see the service link. Basically, these are the radio links establish the communication channel between your user equipments, that is UV, and the satellite to enable the data transfer and the connectivity for the user within the this area which has been targeted. Okay, and whenever we are talking about satellite payloads, okay, so you can see there are different beam, you can say, in a spherical shape. So satellite implementing a transparent payload that generates the multiple beams, okay, over the specific area. So you can see for this particular specific area we have a multiple beam which has been formed, and that is basically covering the defined area. Okay, and facilitating the user in this particular range. Okay, so this is what the overview of how exactly the links and how exactly that connectivity looks like. Okay, so when you will get a chance to go much more deeper, there are a lot of protocols and other eyes involved in this. Okay, so that for that particular I will go with a different video. Okay, but currently we will simply see the generic video that, okay, so we have taken the example of E node B. Okay, so like this particular gateway and the NTN, the satellite basically start behaving like an node B, and then we have a service link to the UV. Okay, and further it is communicated to the core. Okay, so this is simplified diagram which is telling you about the non-terrestrial network archi. Okay, so further we can go and we can check that, okay, why the question comes, why NTN come into the picture. So when we are talking about why NTN comes into the picture, okay, we will be talking about the advantages and the disadvantages of the NTN. Okay, So whenever we are talking about the advantages and the disadvantages, let's first discuss about what are the advantages over the terrestrial network. Okay, so I have listed out what are the advantages, what are the advantages of the non-terrestrial network. Okay, so you can see extended coverage. First of all, so whatever the coverage that we are covering through the terrestrial network, so it will extend the coverage to the hilly areas. Okay, and to the forest and to the mountains to the underground, okay, caves. So in that particular area we will able to give the coverage. Okay, this is what the extended coverage we are talking about. Okay, disaster resilience. Okay, so in this particular, what will happen, suppose due to tsunami or due to earthquake your terrestrial network get destroyed, okay, or it's damaged. Okay, in that particular, basically we are going to evolve, or we are going to use this non-terrestrial network, and this will serve in that particular environment. Okay, recently in war kind of situation, and also satellite company came into the picture, and they basically serve the communication in that particular area. Okay, global connectivity. So when we are talking about the global connectivity, satellite based NTN provide a global coverage, okay, and making it ideal for all the applications that require the connectivity across vast and the remote areas. Okay, in that particular ocean, aviation industry, all will come into the picture. Okay, so that connectivity will we are referring as a global. So it will enable all the IoT devices also. Okay, so basically we are enabling the IoT devices. So NTN supports the Internet of Things, that is IoT applications, which requires very minimum power to work on. Okay, so for that particular IoT connectivity, that is also that NTN also enables in a very efficient manner. And wherever you need broadcasting and multicast, okay, wherever you need that, you need to broadcast to the wide geographical area, okay, and to the large audience. So NTN is a very good options for that. Global roaming, okay, it's enable NTN enables a seamless connectivity for the applications, okay, that require continuous communication. Suppose you are basically in a transport mode, okay, like you want to track a container of a ship or a truck or anything. So in that particular, it plays a very important role. Okay, network capacity load. Okay, so whatever the terrestrial network is, it's a highly populated network now, so it will reduce the congestion, offload what you can say the users and all, and provide overall coverage. So for it will enhance the capacity in that sense. Okay, low power devices support, we have already discussed you in that IoT. And when it enables IoT, okay, cost effective. Anyhow, this will be a little, now the satellite communication, the satellites are not that much costly as compared to the previous era. Okay, so somewhere it will, the satellite cost, in the cost with respect to satellite, that got decreased, so that will be the cost effective. Okay, and it will enhance the mobile edge computing. Okay, so NTN can support 5G mobile, which I'm telling you. So currently, after release 17 and 18, basically it's 5G NTN. Okay, where we are talking about that how NTN can support 5G mobile edge application, providing the distributed computing and the content delivery capability in a remote area, diverse area, geographical location where people were or where the terrestrial network cannot be enhanced, okay, or cannot be prepared. But yeah, when we are talking about the advantages, there are a lot of disadvantages also, like the antenna technology. Definitely it will increase the cost, okay, for the non-terrestrial network. Okay, because in antenna technology in non-terrestrial networks, okay, is a vital for the communication with efforts to minimize the size and explore the electronic direction adjustment. Okay, so in that particular, cost will come into the picture. Okay, high initial deployment cost. So initially when we are going to deploy this NTN, okay, so the cost will definitely increase, because when we are deploying in the LEO, okay, you need to go with a lot of satellites. Okay, the count is more. We'll discuss further. Okay, latency will definitely, as compared to the terrestrial, latency will be very high in this, so we need to work on that. We have a limited spectrum in this NTN. This is one of the disadvantage. Weather and the environmental factor, that is whenever there will be a environmental factor or a kind of bad weather condition in that particular, basically your satellite is not going to much more effective in that particular scenario. Okay, there will be a lot of interference, noise, signal distortion. Okay, major concern nowadays with 5G, 6G, or you can say the NTN, security and the privacy concern. This is one of the major concern in this NTN. Okay, that how we are going to secure the data. Okay, which is coming or which is transmitted via satellite or to the other NTN technologies. Correct, because the interception or hacking are like very much nowadays prominent. Okay, deployment and maintenance, really it's a very big challenge. Okay, and cost will come into the picture. So people are working on this, how to minimize this deployment and maintenance cost. Okay, energy consumption, which is very much crucial topic nowadays. Any energy security, deployment, these all are like big concern when we are moving towards 5G and 6G. Okay, complex handover. Okay, so when you are giving the handover to a terrestrial non-terrestrial network to the terrestrial one. Okay, this is also one of the complex tasks. Okay, or handover to the multiple devices. So these are the disadvantages of the NTN. Okay, further there are type of, what are the type of space-bound platform. Okay, so we will discuss on this. Okay, what exactly this is. So when we are talking about the space borne platform. So the airborne, basically the airborne category includes the UAS. UAS basically, it's a term being used here. Okay, it's an unnamed aircraft system platform. Usually, this we can put it on the altitude from the Earth. So suppose this is the Earth, then we used to put it, that particular system, at a height of 8 to 50 kilometers. Okay, and it includes your HAPs also. Okay, that basically we used to put around like 20 25 kilometer. Okay, so UAS, basically when we're talking about the UAS, okay, that is unnamed aircraft systems, is like a geo satellites. Okay, I will discuss about the geo, leo, and MEO. So geo satellite that can be maintained, that can maintain a fixed position related to the space. Suppose we have a ground, suppose we have, with respect to this particular, it will be having the fixed position. Okay, with the beam fruit, so it will be, it will, suppose this is the fixed position and it will be providing the beam, and that beam footprint can be from the 5 kilometer to 100 kilometer depending upon your satellite capacity. Okay, spaceborne and the airborne platform fall into the two distinct configuration based, okay, on their payload. So based on the configuration, we are categorizing the spaceborne or the airborne. NTN platform are equipped with either transparent or regenerative payloads. So I have already told that this will be based on the payloads. Okay, so there are basically two type payload we will discuss. Okay, transparent and regenerative. Before that, we will discuss about what exactly geo, leo, and so simply I will go with the simple definitions. And also when we are talking about the geostationary earth orbit. Okay, the height for this will be more than 35,000. So it is 35,786 kilometer. Okay, when you talk about the leo, is low earth orbit, that is 300 to 1500 kilometer. And the medium orbiting satellite, that is MEO, that is 7,000 to 25,000 kilometer. Okay, so when we talk about the leo, offers the coverage at the you can say continental, regional, or the local level. Okay, and this, the orbit that we are going to use for this is a circular around the earth. Okay, typically the beam size that we are talking about. Okay, so a beam footprint, that the coverage that we have already mentioned, that what kind of, up to how much kilometer, so it will be 100 to 1000 kilometer When you talk about the geo satellite, they will give 200 to 3500 kilometers, and when you talk about the MEO, it will be 100 to 1000 kilometers. Okay, this is what exactly the footprints. So LEO satellite constellation can deliver services both on the northern and the southern hemisphere. When we talk about the LEO satellites, okay, when we talk about the MEO one, okay, so these satellites are positioned, basically we used to position in the middle altitude orbit, okay, offering a balance between the coverage and the latency. So here we are focusing on the coverage and the latency both. If you go with the other aspects, there are other aspects also with respect to these satellites, okay. Other aspects is like orbital period. So what will be the orbital period for the geo? So this will be the orbital period like 24 hours, okay. When you talk about so geo will be like this 24 hours. When we talk about MEO, so it can be 2 to 8 hours, okay. When we talk about the LEO, it will be 10 to 40 minutes, okay. Heights, already I have told you what kind of height it is going to offer. When you talk about what will be the satellite life, okay, so LEO will be having always a short life than the geo and the MEO, okay. Propagation loss will be least in the LEO, but it will be high on the geo satellites, okay. When we talk about the number of satellites that is required for geo, the geo one, basically when you talk about the number of satellite that is required, three, okay. When you talk about MEO satellites, so it will be required 8 to 20 satellite. But when you talk about the LEOs, that why it is like cost will be involved. So 40 to 80 satellite will be required in this, okay. Advantage is, anyhow I have mentioned you, geo will cover definitely a large geographical area, and MEO will be a little bit less than geo, and LEO is anyhow covering a smaller area but with a good signal strength, okay. This is what exactly we can discuss, or this is what exactly I have told you about these two orbits, okay. So further, if you will go, let's go to the different topic now. If this is the 3GPP release I have mentioned, like in 2018, you can see around 2019 Q2 release 15, and then release 16 in 2000 Q1. So from this particular release 16 half, okay, like Q4, we have started working on the NTN, okay, which includes your 4G, and then now we have in release 17 it's 5G-NTN, okay, and it's going forward in release 18 it will be also there, okay. So this is how exactly. So the effort within the terrestrial technical specification that we are talking about, that is release 17, okay, that is basically integrating the satellite capability, okay, in this particular release, okay. Now we, when we talk about, I have already mentioned there are two kind of payloads, okay, the transparent payload and the non-transparent payload, okay. So we will discuss little bit on the transparent payload and the non-transparent payload, and then we'll move forward, okay. So when we talk about the transparent payload, okay, see, this is the example for the, let me write it, transparent payload. And by the figure you can see we have a UV, and we have a remote radio unit, okay, in which you can see the satellite and the NTN will be considered, and then we have a G node B which is further connected to your core. So basically this is your NG RAN, and this will be further connected to the core, and then with the N6 interface it is connected to the data network. So what exactly is happening in the transparent payload? In a transparent payload scenario, the satellite operate as an analog radio frequency repeater. Okay, so basically all the digital processing that we are talking about, that is basically done by the G node B at the gateway. Okay, it's are both The feeder link, you can see the feeder link and the service link, okay, without modifying the transmitted signal, okay. And when specifically when we're talking about the 5G, the satellite includes UAS, that is unnamed aerial system, and act as a medium for replicating the 5G NR-UU, okay, this interface, okay. The satellite does not alter any signal passing through it in this particular communication, in this particular type. Okay, it ensures the seamless transmission of the data from the feeder link to the service link. I have already told you what exactly the feeder link and the service link is. Okay, so this is basically the feeder links which is in between the satellite and the gateway. So here you can see the satellite and the gateway. This is what basically your feeder link, and UV and the satellite, that we call it as a service link, okay. Now let's talk about the non-transparent payload. So in the figure you can see, when we talk about the non-transparent payload, so the satellite plays a central role in the signal regeneration. So this is what we call it as a regenerative, also non-transparent or regenerative payload, okay. So this will be using for bridging the communication between the Earth and the satellite network. In this particular, you can see the NRUU. The NRUU interface functions as a service link. It will facilitate all the user equipments. On the other hand, you can see the feeder link. Okay, feeder link. Okay, so on the feeder link, the satellite will be employing or will be using the N2 and the N3 interface, okay, forming the satellite radio interface, okay. So whenever we'll go much more deeper, then we'll go talk on that particular what is satellite radio and other interfaces. And this setup effectively position the G-Node B or the 5G station within the satellite, okay. So within the satellite only, this satellite will be working as a G-Node B. You can see within the satellite it will be it is like it's act like a base station, okay. In regenerative payload, what exactly? Actively enhance the signal. It is completely enhancing the signal, doing the error correction, modulation, demodulation, amplification, all will be taken care. Okay. And in this regenerative payload, basically they support the bidirectional communication. Okay, exchanging the data between Earth-based station and the user equipment. So, okay, and data may be undergo the transformation within the payload. Okay, in this particular operator will be having a lot of plus point, okay. They can have the control over the quality, network performance, data integrity and all, okay. And the implementing of the regenerative payload, basically it's a complex part, okay. So adding means acting satellite as the G node B, it's a very complex part and the cost oriented thing, okay. So this is what basically the difference between this transparent payload or non-transparent payload or regenerative payload, okay. These are the operating bands as per the 3GPP N20, 256 and 255. Okay. In the uplink and the downlink, you can see both are FDD, and these are basically the range for that. Okay. So you can go through, um, you can say the 3GPP spec, and you will find this. Okay. Now, basically, and SIP, we are not discussing now here, but SIP 19 will be taking part, will come into the picture while this NTN configuration and NTN will be in the scenario. Okay. One more thing, and the final thing that I want to discuss about, that is the use cases. So what are the use cases of the NTN? Okay, so whenever we are talking about the use cases, okay, whatever the advantage we had discussed, so that is the rural connectivity, okay. So whatever the remote area, the rural connectivity, these are the use cases. Disaster response, whenever there would be a disaster, tsunami, war, earthquake, anything will be happen, okay. So natural disaster or man-made disaster, there basically NTN will be like one of the use cases, okay. Maritime aviation communication, I have already mentioned, like in an ocean or in an aviation department where exactly we are talking about the flights and all, there basically it will come into the picture. Agriculture is one of the important part in the precision agriculture. NTN supports a small IoT applications, okay, for the monitoring of the crops, weather condition, and all. Okay, mining and energy sector, there also IoT, basically IoT, logistics, shipping, transportation, all this thing will be easily taken care or integrated on the NTN. Okay, global supply chain, global roaming will be enabled with this NTN. So these are use cases. Once we will deploy all this NTN network, then it is definitely the cost effective one. Deployment will a little bit costly, but yeah, that will be cost effective further. Okay, and when we are talking about the players, okay, so Starlink, Starlink, one of the big player in this. Okay, the HughesNet, Viasat, OneWeb, Amazon, Geostationary, Teleset. So these are the lot of players are there in this. Okay, who is going to play a very vital role. Okay, in the NTN, and this is going to be one of the big advantage, or one of the big chunk of area where exactly the wireless industry or wireless engineers will have a lot of thing to do. Okay, so this is what exactly from my side for this NTN introduction. We will have one more session further for much more detailing. Okay, but for today, thanks everyone for joining the watching this video. Okay, stay connected with us. We will try to make videos on the other latest topic. Okay, like 6G and all the things related to 6G going forward. So thank you. Thanks everyone.